Okay, so what are our objectives for this lesson? So we're going to look at compare internet connection types, use basic TCP/IP concepts, compare protocols and ports, compare network configuration and network configuration concepts. So this is going to be our objective for lesson 5. Again, we're going to compare internet connection types, use basic TCP/IP concept, compare protocols and ports, compare network configuration concepts. Okay, here we go. Okay, so 5A. So 5A, we'll look at compare internet connection types. Okay, so now this is a typical scenario of what happened in an organization, right? So it could be a sole network, which is small office and home office network. So you have your router in your house. So you have a router in your house where you have that supplies internet also. So that same router to also provide network connections for your devices. Like these are network connections for your PCs, your devices. So this same router provide network connections and also supply internet. So since the wireless network, so here we have the wired network, then we have what wireless devices. So here we have these are wireless devices, all these wireless devices here. So what happens is that the wireless access point provide also internet access to the wireless devices. Why for this one and to the PCs also get what they get internet access through this cable, because these are cable network. You see them. These are wired network. Why this is what wireless? So here is the ISP that brings out the internet. All right. Okay. So we have some few keywords here that we just explain briefly. So the internet. So here we have internet exchange points. So you just see the internet exchange points are just a company with 2 or more offices at different places where they can be able to connect themselves point to point. So you have an office in this location, and you have another office in another location. So you want to ensure that all these locations, they all, be able to exchange internet connections together. They can be able to communicate. So what you have to do is just to put a wireless device there, that we're able to connect from this your branch office to the other one, and like that. By so doing, once they can connect with each other, they can be able to exchange, network information. Then of course also have another way of providing internet is through the internet service provider, which most of us already know. So ISPs are those that provide internet. So if you want an internet, you can go to an ISP, so they can just provide the connection, everything for you. So we also have point of preference too. So point of preference could be a way you connect to the internet, which will be a point-to-point link or digital modem type. So when we say point-to-point link, links, we're just referring to 2 branch offices. So you probably have one in London and you have another office in Liverpool. So you can establish a point-to-point connection through the router. So you have one router here that will link to the other router in Liverpool. So those are kind of what we call point-to-point links. So then also have a digital modem too. Back in the days, modem is one of the most connection that's being used, technology that was used for internet connection back in the days. So modem was used, telephone modem was being used for be able to make all this digital connection. But now, technology has evolved so much that even with your phone, you can be able to get internet. Phone device can provide you internet. Your router can just do that for you. So we're going to look at router versus modem now. For this one, uses router. Point uses router. This one uses modem. So we're going to look at 2 of them. Okay, so let's see this is a practical scenario of a network with internet connection, right? So what you have here now, this is a LAN network. A LAN network with IP addresses. So you can see all these are IP addresses. All these are IP addresses. Now, if you take a look at this IP address, you'll notice something. Notice that it has a slash 24. Right? What is this telling you? And compared to this one, say 192.168.0.1. This one is saying 192.168.0.0.24. So this slash 24 here is just telling you about the numbers of bits that are on. So if you are new to IP addressing, like I said, we're going to have a special class. In a network insertion class, I'm going to explain IP addressing. This class to show what it means. I'm going to explain IP addressing, I'm going to explain subnet marks in a very comprehensive way. But just know that slash 24 is telling you about numbers of bits that are on. So that's what it's telling you. So you know what it's telling you about the subnet mask. So subnet mask is what divide our host portion from the network portion. Again, if you don't understand host portion and network portion, I'll just say a little bit, but we're going to have a special class, which is the network and essential class, which I have to explain all those things for you. So A+, they assume you know all these things, so they didn't go deep to explain them. But let me just tell you, typically an IP address is a unique identifier that identifies computer and network. So every computer, when they go to the network, they must have an IP address. So that IP address identifies those computers on the network. Today now you're on the internet. You're on the internet because of an IP address. So every device, including your phone on the internet, they have an IP address. So that will identify them on the network. Now the IP address is divided into two parts. So we have the first part we call the network portion, and the other part called the host portion. So the network portion of the IP address is the part that's like a street address, a street, right? A street address. So everybody in that street must have the same address. That's the network portion. Then the host portion of the IP address is like your own address, your house where you stay. So if you live in, for instance, Bowen Street, right? So your Bowen Street is your network address. Now, where in Bowen Street do you live in? Where in Bowen Street? If you live in number 5 Bowen Street, so that says Bowen Street network address number 5. Number 5 is what? Your host portion of the address. So the host portion is different. The network portion identifies the host on a given network. The host portion uniquely identifies that host in that given network. Right? Good. So, like I said, we're going to explain this practically. I'm going to show you practically through the computer system, how to do it. I'm going to explain the bits for you that are on 2024. I'm going to explain them to you. So again, subscribe to our channel. Always like our videos. If you have a question, you can put it in the comment section. So I'm going to talk about all those things as well. So after the whole of this training, I'm going to spend time after the whole of CompTIA training, which we're going to finish, core 1, core 2, we're going to finish it. Then watch out for our video on network essentials. So that will be granted so much. We'll give you in our previous class, we talk about network topology. We're going to explain topology for you too. We're going to talk about IP address, IP version 4 and IP version 6 address. So much is going to come forth in our network extension class. Okay, so now this is the IP address that we just explained the two parts. So we have host portion and network portion. So for this subnet mask, the subnet mask is the one that will make you know which part of the address is the network and which part is the host portion. So this 24 already tell you that this 1, 2, 3. So we didn't say that, but an IP address an IP address has two types, version 4 and version 6. So version 4 are usually the most typical one. They're made of 4 octets, 1, 2, 3, 4. This 1, this 2, this 3. So 24 bits means you have 8 bits here, 8 bits here, 8 bits here, which gives you 24. So this portion 191.0 is called the network portion. That means every computer on the network will have 192.168.168.0. Every computer will have that address. So it's like a sister address. Everybody will have it. But the other portion is going to be different. So you that live in the same street, in Bowen Street, You have everybody that live in Bowen Street, they bear Bowen Street, right? But they don't live in number 5. You only stay in number 5 Bowen Street. So someone will stay in number 7, number 8. That's the IP address. So you all have the same network address here, 192.168.0, right? But the host portion will be 1. Like that what I see here. This one means 192.168.0.101. Similar to this, 192.168.0.1.102. Same with this. All these devices, like these are wireless, but they all live in this same street address. So they all bear the same network address. They all bear the same network address. But the host portion of the address, which is this last one, is going to be changing. Here you see 0, right? From here, you know. So, like I said, just stay with us. We're going to explain so much to you, right? So this is this typical application of the ISP. So this is the LAN, right? Now, if you look at the other side of the address, this look at the public. So this is private, this is public. Public is a wide area network where the internet comes from. So this you can control, but the public cannot control. So how do you get the internet to your LAN? You have to go through the router. So that's why this one is here. So this router now connects to your ISP. So your ISP the internet. So this is the internet address. See, this is the internet address. See, this is your internet address for ISP that comes into the network. As soon as it comes into the network, this is your one network will be translated. There's what called NAT. It's called Network Address Transmitter. So what it does is it converts a public address. This public address convert it to a private, so your devices in your local LAN can be able to have internet. Oh, good. So, okay. So we are talking about modem and router. So these are modems. So most of these modems, they are obsolete. Most of them, they are not being used again. Back then, is normal. The modem we use telephone lines to subscribe to DSL line. See, that's how it is before back then. So it's a telephone line they use. Then telephone line too can also have the modem can also have internet this thing too. So this telephone line can come from outside. Then this your internet go to your normal LAN network. So telephone line comes in here and here your Ethernet for your LAN network, right? Okay. So cable modem. So the same thing. This one now is what we talk about, like this one now we talk about quasi cable, right? So this is a quasi cable. We'll explain type of cable here in our previous lesson. So this is quasi cable, right? So you have a quasi cable here. You can see look quasi cable with F-type connector. So this one connects from the ISP. The way this goes towards your LAN, right? So you can have a modem like this. Okay. So also have a kind of modem too. There are a lot of them. You have a modem too like this too. So you take a look at the modem like this, right? So let's continue. These are most of them are not so necessary. Let's continue. Okay, so let's look at cellular radio internet connection. So cellular radio internet connection is simply your mobile telephone line, your mobile devices, which we call GSM. That is your CDMA. Collision division multiple access. So that's what this one means, right? So that they have your SIM, you must have your SIM, and you could be using 3G, 4G, or 5G. So now a lot of people uses 5G now. This is 5G all of people use now. So routers. So we just look at modem now. So let's look at routers. So routers are the reason today why we go to get internet access to our network. So routers are the reason today why we can work from anywhere you are. You can be able to work with somebody in Japan, someone in US, because what router does, router bring, networks together. They connect different networks together. So your router can connect two LAN together, two network. They can connect long distance network, like one. They can connect them together. So here now we have a LAN router. A LAN router is what connects two subnetwork together, two subnetwork. when I say subnetwork, what I'm talking about? Okay, let me explain. A subnetwork, right, is a network that is being what subdivided to smaller part of network. So you have one network, right? And if you notice that the network is just too large, you can see traffic, network congestion, you could break it down to subnetwork. When you break it down, what you've done, you split what? You've broken down the traffic to smaller particles. When you break down the traffic like that, what happens? You're going to use what we call router to connect them together so they can be able to still communicate. So when you do that, you're going to notice that certain things, is going to happen. Like one of those things you notice that the router can be able to connect to other devices, other networks, and they can share information. So a router connects a subnetwork together. Apart from SEDN, they also connect other LANs together too. So if you have a network in this office and you have another network in another office, you can use a router to connect two networks together. So the same way too, LAN, the router connects to one network. So one networks are bunch of LANs that span through geographical ranges. So all your internet you see, they are one network, all your internet. So your internet you see is one network, and then your office is one network, and that network is there. So all over the world, there are all networks all joined together to form what our internet. Right? So that is it. So okay. Okay, so now you can have firewalls. So firewall are just rules that we use to handle packets. I mean packets, I'm talking about what? Traffic that comes to our network and goes out. So how you handle them. So you can create rules to deny, and block. So you can create your firewall, create a firewall rule that will deny maybe some IP address from coming in and from some going out. You can also create a firewall rule that can block specific services. Like maybe you don't want emails to come to your network. So you can create a firewall that can block email, from coming to your network. So you can either block or deny. Those are firewalls. So you're blocking or denying. But we need to understand something now. In terms of firewalls, we're talking about firewalls rule. I see firewall rule. In firewall rule, deny. If you create several firewall rules and you put a deny somewhere, that deny will take precedence over your allow rule. So deny rule always take precedence over allow, like block rule. So if you are doing it, you create a firewall and you are saying block, and somewhere you put allow somewhere to allow that traffic. So long those traffic are in the same way, that deny one will be taking precedence over the allow you put. So you have to create a firewall separately. Right? Okay. So for what is firewall? Some of you don't know what is firewall. Firewall are just security features that can prevent an intruder or an unwanted user from gaining access to your system. It could be your device or whatever, but you just want to prevent an unauthorized user from accessing your system or your devices. Those are firewall. You can do that by creating firewall rules. You can create your own rules to firewall. So also we're going to do that too in our networking essential class. We'll create rules too. Okay, so let's look at TCP model. Let's look at TCP/IP model, right? So one of the most important topic in computer networking is TCP/IP. That's one of the most important topic in networking is TCP/IP. So how the computer communicates with one another, how they share information, all those ones are being regulated by TCP/IP. So TCP/IP is a very important protocols, when it comes to networking. Very, very important topic in networking. So it all talks about how data move from one layers to the other, how computer be able to communicate, how computer be able to communicate with several services and applications, right? Okay, so we need to understand TCP/IP is a model. I mean, a model is a layer approach protocol. So I mean layer approach, I mean that it's been broken down to simpler method for that help to simplify and ease communication. So what we have here now, we have four layer approach here. The first one is the application layer. Second layer is transport. Then we have the internet and the link and network interface layer. Right? Now just take a look at what we have here now. Right? So here we have a layer called application layer. So the application layer, right, is that time when you're working with the computer system, like I'm doing now, I'm seeing everything you see, the output of what you're getting, right? Like you do a file transfer, you do telnet, this is an example, SMTP, you receive email, simple network management, IMAP, all DNS, all these are form of what? Application layer, things that you see that happen physically, result you get, they're called the application layer. The transport layer, all right, is broken down into two, TCP and UDP. So this one called TCP, called Transmission Control Protocol. Why UDP is called User Datagram Protocol. These protocols, they call transport. That's the reason why communication can take place in networking. Without these two protocols, there's no communication. Two computers cannot communicate without TCP and UDP. Especially the TCP. We call it TCP a reliable protocol. Very reliable. Why is it reliable? Because the TCP always seeks for an acknowledgement after every transmission is completed. There's an acknowledgement. UDP does not do that. Right? Again, stick with us. I'm going to spend time to explain all these zones in network and extension class. I will explain all of them very well. TCP, UDP. I will go from the very basics and explain deeply. So just for the sake of A+, you wish A+ expect you to know all these things because you didn't go deep down to explain them. So I'm going to spend time to talk about all those things in our network and extension class. So, like I said, the TCP is a reliable, it's called Transmission Control Protocol. So that is a protocol that is used mostly in network communication. UDP is called User Datagram Protocol, it's unreliable. Now, unlike TCP that seeks acknowledgement after a transmission has been completed, UDP does not seek acknowledgement. So we call UDP unreliable protocol. Now TCP has what they call sequence number, that flow, so many things that TCP has that if I say them now, I'm going to want to talk about them. We're going to go further. So let's just leave it like this. Just know we have two protocols in transport layer, TCP and UDP. One is reliable and one is unreliable. So this one is a reliable protocol. This one works. And why is TCP reliable? TCP always seeks acknowledgement. TCP does something so interesting. The work called a three-way handshake, a call setup. You call it virtual circuit. So all those things have to do with before computers communicate, they must know if the other computer is alive or not. So how they do that? They can send a word, make initial, like a broadcast message, trying to discover who is this person. I'm this person, this is my IP address. I want to communicate with you. Can you confirm that you are this person with this IP address or this hardware address? So this person, the next person has to communicate. Okay, I'm the person. No, we can ask that communication. So at the end of that conversation, TCP afterwards send an acknowledgement. That's how I say TCP is a reliable protocol. Okay, so let's come back to this place. The internet. The time you have to work on the internet, you browse everything, that is protocol, this layer that does that. We call it IP protocol. So we also have another protocol, ICMP. This is a messaging protocol for like when you're browsing and you're getting a request timeout. This is a protocol that is doing that for you. You get a request timeout, the site is not going, this is the protocol that does that for you. Right? So the internet protocol is what we call it a routing protocol. So it helps you to move from one network to the other over the internet. So that is a internet protocol. It's a routing protocol means that a protocol that can move from one network to the other. That's what router does, right? Well, now so we have the link and network interface layer, right? So in this layer two, in this layer now, in this layer, we have some interesting protocol here, ARP, address resolution protocol. We have some also interesting protocol here for network layer. So it's called point-to-point tunnel protocol, layer 2 tunnel protocol. All these protocols, they are encrypted protocol that help to, for instance, you're doing a VPN connection now, right? A VPN connection has to be what? Encrypted over the internet. So if a VPN connection ensure that you are in a insecure network, and for an insecure network, you're trying to access a secure network over the internet. So VPN connection ensures that whatever you are doing, right, your information is remain hidden over the internet because you're trying to access an unsecure network. So a VPN connection allows you to walk through a unsecure to a secure network, and from a secure to an unsecure. So that's what VPN does for you. So they encapsulate everything into an encrypted format that when information goes over the internet, they're not being visible, they're not being seen, they're being encrypted. So also we have the Ethernet card too. They come under this layer, this layer, the network card, they come under this layer. Again, stay with us in our network essential classes. We're going to explain all these things in full. Okay, so now earlier I was explaining IP addresses to you, right? I was explaining IP addresses. So now we just have some few things I just have to talk about here. So this is an IP address. So IP address is actually two types. So you have IP version 4 addresses and IP version 6. So if you are wondering what is IP address, I said it earlier, right? So IP address are just a unique identifier of computer on a network. How you can identify computer on a network. Every computer on a network must have an IP address. So those are numbers they give to assigned to computer so that they can communicate and they can belong the words in the network. Right? So the IP address has 4 octets. Right? We call them a 32-bit binary number IP address. They're actually 32 bits. So in computing, when you have binary, you're referring to 0s and 1. So on say 32-bit digits, it means that if you count this number now, that 32. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. Just count all until you get there. You're going to give you 32. Now, each of these 32 you see, they're broken down into 4 parts. That's what you see here. 4 parts. Look at it here. See? Divided into 4 octets, 4 parts. See? Of 8, 8. So this 8, this 8, this 8, this 8. Right? Now, when you convert all this part, convert it now to decimal, you're going to get 192. Convert this part of 8 now, you're going to get 168. Convert this part to decimal, you're going to get 0. Convert this part to 1, you're going to get 1. In our network essential class, I'm going to show you how to convert them to decimal. So many are going to do network essential class. It's going to be very big. So watch out for that class, right? So now, these numbers are in decimal numbers. So your IP addresses in computing, they appears in 0s and 1, but what you see on your computer is you see the decimal format. But in computer is in binary format 0s and 1. So these are the decimal format of IP address. So I explained to you earlier that IP address is divided into 2 parts, network portion and host portion, right? Okay, that's fine. So okay, let's continue. So now, I also talk about the network host and the network portion and the host portion again. Yeah. So the IP address has 2 parts, network ID and host ID. So these are the network ID. You see, usually 192.168.0. I explained it earlier. So you see, 255, 245, 255. This number here means all the network portion are, see, 1, so all these 1, 1, 1, 1, all through the network addresses. Because when all the network ID portion, all the network portion of the ID are all 1, all true. That's the network portion. See, all of them are 1, 1, 1, 1. So when you convert it, it's going to give you 255. So when you see 255, 255, 255, is that is the subnet address, subnet mask address. See? Subnet mask address. So the subnet mask address is telling you that all these portions you see now, that are 255, they're all 1, 1, 1, 1, 1, all true. So now the 8 bits, they are all turned on. So 1 means on. See, that's what you see here. See, all of them are on. Then the portion that is off is for hosts for assigning computers in the network. So it means that if you have, right, if you have 20 computers and they all use /24 notation, means that what? You count the what? The binaries. Each octet to take 8. So the first octet is taking 8, second octet 8, that's 16, then the third octet is what? 8, that gives 24. That's what you see here. It means that what? This is your subnet mask. So the remaining octet, which the fourth octet, is 0 because it's ending 24. That shows if you want to start assigning IP address to computer, you're going to start from the last octet, which means that whatever is on this format, right, will not change. They will be the same. Like for instance, this one 192.168.0. This is an IP address. This address is a network portion. This address will not change. It will be like that. All true. It's not going to change. Right? So why this one is going to change? So that means if I have 20 computers, I'm going to say 192.168.0 network portion. Then this portion I say 1. I go to another computer, I say 192.168.0. This portion I say 2. So that's how it will be. So all the addresses, all the computers will bear this 192.168.0 because why? They're on the same network. So computers on the same network can communicate easily because they bear what? Same network. That's why I talked about the street address earlier. So since you all live in the same street, you want to bear the same street address, but our local addresses is going to be different. Right? Okay, so just follow us, stay with our channel, stay with our trainings. We're going to spend time to tell you about most of these things later. Okay, so now understand this. They say IP version 4 forwarding. Now let me just explain this to you. When we say IPv4 forward, what is it saying? Now, an IP address, right, that is in the same subnet, the same destination, they're all on the same network. They will share information between themselves. They can communicate easily. But an IP address with a different destination address, different, that address will be forwarded out from the network because they are not the same. They will be forwarded out. That's what it's saying. You see, host must determine whether the destination address is on the same network as its what source address. So a host has to see that if a computer has a different address, the host must look at the network address. Okay, are we the same network? So if they are not the same network, that address will be forwarded out on the network through the router. That means that IP address is not in the network, so we'll forward it out. Now, see, use mask to compare network ID in source IP address and destination IP address. What is mask? Network mask. So the network mask now is this 255 we explained earlier. So that's what you're going to use. So 255, this is the network portion of address, right? So you look at if here we have 192.168.1, right? And here we have 192.168.0. Now these are two network addresses. So see 192.168.0. This is one network address. 192.168.1. Remember the network portion, you don't change them. So when you have two different 0 and 1, means that this is another network. 192.168.0 is another network. This one 192.168.1 is another network. So these are separate IP addresses. All right? So that means these are two different networks. So if you're going to start here, number computers, now you're going to say 192.168.0. Right? Here they say source, they say destination. Why? Because there are two different networks. So in this place now, one will be this, if you're going to give computers IP address, you're going to say 192.168.0.1. Then you get 192.168.0.2, 192.168.0.4. That's how this network is going to represent till they get to 100. If you come to this other network, 192.168.0.1, every computer in this network will bear 192.168.1. But the last portion, 1. Then again, second computer, 192.168.1, 2, on and on till they get to 100. Right? Okay. So stay with us for our video on that. We're going to explain those things to you. Okay. So usually IP addresses are of two types. So public and private addressing. Public addresses are routable across the internet, like we explained earlier. So public address that goes over the internet. So we call them public addresses. So it goes over the internet. So they go over the internet. We call them routable address. They go over the internet, right? But the private one, they are restricted within our internal network. They don't go outside our network, they're within. So if you need to get, if you need to get, to a private network, if you need to go out to the internet, which means you need the public addresses, that's where the router comes in. So the router will help work on NAT. You see, a NAT. NAT is called a network address transfer. So that public address cannot work on our internal network because it's a routable address. So what we have to get a device called NAT. So which our router actually do. Most of the router, they have inbuilt NAT. So inbuilt NAT means they will convert those public address from the internet into private so that you can be able to browse on your computer. That's why today you can browse, If you're in the office, you are working, you are browsing, right? Why are you browsing the internet? Because of NAT. NAT is not doing that. Because the address you used to work on a computer, the address the computer used to communicate on your network, right? They are private addresses. So but for you to go out in the public, so the NAT will not do that for you. So these are private addresses type we have. So take notes, look at them. 10.0.0.0/8. So we explain this on now. We use this 8 bits on, right? 1, 2, 3, 4, 5, 6, 7, 8. That's what it means. It's on. If you convert, you're going to get 255. Similar with these two. So here we have 172. Here we have 12 bits. 172, 168. Convert this one now. You're going to get to decimal. You're going to get this. So all these are the private. So we have 3 private addresses. Again, don't worry. Stay with us for our network extension class. I'm going to explain all this one for you that you can understand it very well. I'm going to explain all to you. All right. So we also have addresses, classes, and default subnet mask. So every network will have a default subnet mask. Every network will have a default subnet mask. Very important. All right. Subnet mask address is the address of the router. Default gateway, rather, is the address of the router. Default gateway address. Router. Your subnet mask, we will explain is that one is what help us what know which part of the IP address is network and which part of the IP address is what host portion. Right? Okay. So when we say a proxy service is just if you need to go outside the network, at times we have proxy server, right? A proxy server is just like an intermediary. They act on behalf of something. That is what proxy service. So they are not the main person, they'll just be acting for you. So at times you can have a computer that has internet already. So for that computer, what it does is to bring the internet. So if you need to go to you need to get the internet, you have to get to that computer first. So most router too, they provide proxy service. Because why? The router has the internet. So you can't go to the internet except the router. So the router can give it in, so they provide proxy service for you. Okay, now here we go now. So see now, take a look at what we have here now. Now, see this IP address. These IP addresses are classified. So here we have 192.168.0.2. This address of one computer. See, we have the subnet mask I will explain. Right? 255.248.2.0. What does it mean? It means that what? This portion 192.168.0.2 is a network portion of the address. That shows that every computer on that network will have this 192.168.0. 192.168.0. Every computer will have this address. Every computer will have it. Why the other ones can be 1, 2, 3, 4, like you have 2. Right? Take a look at this one now. Take a look. Default address 1. This 2, this 1. Why is it like that? I'll tell you why. This is 1 because usually your default gateway address is what take you out from your network. So your router usually we call them what default gateway because the router takes you out from your network. So router takes you out from your network and also bring you in. So each time you are going out of the router, is a default gateway you are passing through. Just like a door, before you can pass through your house, you have to get to the door. So anybody that is coming to your house too, they have to pass through your door. So that's what the router does. So by default, in most cases, right? Most cases, your router addresses of your network, they always take 1. They take the first IP address. That's why you see 192.168.0.1. Then the client, that computer is giving 2. So DNS 2 So the same way, what I'm saying is that this router you are seeing here, they have the same address, which means the router you have is also a DNS server, does the same work as a DNS server. Right? So we're going to talk about DNS too. What DNS is, we'll talk in our next video, we're going to talk about DNS. Then we have alternate DNS. Alternate DNS is like in case the first one failed, you can go to the next one. Okay, so good. Now, there are two ways to assign IP address to a computer. So either you're going to do it manually by yourself, or you're going to let the server do it for you. So two ways: static versus dynamic host address configuration. Static means that you go to the computer like you see here now. You go to the computer by yourself, you type it by yourself. 192.168.1.0. So if you have 10 computers, you have to go to your 10 computers, be typing the IP address one after the other. That's what static means. Now, what about automatic dynamic host IP configuration? Dynamic host configuration means that you just have to have a system, a server that will act as your DHCP server. Look at it. To actually DHCP server for you. So what it does is it works with what assign computer. So as soon as the computer just come online, the server will just give them IP address. So you don't need to bother about you going to each computer. The server will give them IP address. We call it DHCP. It's assign IP address automatically to every computer. Right? So that is DHCP. That's what DHCP does. So the two differences are static, you do it yourself. So in static, you the network administrator, you have to be assigned every computer on the network. Dynamic, just get one computer, then you set it up as a DHCP server. So you're going to configure everything. Right? When you configure everything, then you can see that it's going to by itself start assigning computers in the network IP addresses. Now we also have this one very, very important: automatic private IP addressing, APIPA. This one is very important in A+ exam. When you see any address like this, 169.254, that address is a different address. It's an automatic IP address assigning. Now, what does it mean? This one is very different from this one. It's not a DHCP address. Now, let me tell you something now. When you configure DHCP server to give IP address to your computer, so what means is that your computer at all time will wait for DHCP server to get an IP address at all time. If your computer is waiting to get IP address from this server, this DHCP is off. The server is off. You cannot give your computer a IP address. The computer by itself, the OS inside, will by itself give that computer an IP address that is not a DHCP address. Why? Because at that time the computer needs IP addresses. You go for IP addresses. The DHCP server is unavailable. Sorry. The DHCP server is unavailable. The DHCP server is down. Right? So at that point in time, what happened is that the Windows by itself will assign, give IP addresses to the client's computer. So when it does that, that address is in form of 169.254. So this XY could be anything, 01, whatever I see there, but where you have these two octet as 169.254, you know what that address what? An automatic private IP address. That address can never be part of the network, it's on its own. So if you see the address, you can't access the network, you can't do anything, it's on its own. So how do you troubleshoot that address is, we're going to tell you too, how you troubleshoot down. We're going to tell you. Maybe later on about network troubleshoot, we'll tell you about to troubleshoot those kind of addresses. So you have to go and disable the network card, you have to freeze, you have to reconfigure, you have to release, That's how you can be able to set that system again. Okay, so I'm sure we are understanding me now. Okay, so now the next one is how to set up, how to configure a router, right? So these are just basic router setup of configuration. We're going to also do all this in practically too. So these are basic router configuration, basic one. See, basic router configuration. So these are you set up a basic router configuration. So I'll do it practically. So again, keep following our video. I'm going to show you how to set up this. Keep following subscribe to our channel. So I'm going to show you how to set it up later on. So I'm going to get a router, do it practically, and you'll be able to see how to set up your router. But know that every router you buy, you have to set it up, put an IP address inside. So we'll talk about the router itself, right? The router has an interface, right? So that interface that we used to manage through the web. So this router is a web-based management interface. You know, this is a web-based. So as long as you're on the router, it use the IP address, right, of the router, the connecting. Don't worry, I want to do it practical for you, right, so you can be able to see that. But if you have any question, you can just send me a message through the comment section. Then I'm going to reply you. I will explain more about this. Okay, so very important. So the next thing now is IP version 6. So I said we have two types of IP addresses, IP version 4 and IP version 6. So IP version 4, we said it was the 32-bit addressing scheme, 32 bits. But version 6 is not 32-bit addresses. It's 128-bit IP addressing scheme, 128. So the same way, we have two parts of it, the network part and the interface part, which we refer to as the host parts. See? So this network parts, right? If you take out these network parts, they are of two types. One of two types. So we have a part that we call the there's a part we call the global routing, which is called global addressing. See? We call it global addressing. All right? So the global address means that from this is 4 bits, they use 48 bits for global routing. So what does it mean? Now, this is the address that makes the computer to move from over the internet, from different network to another network. That what it means. You see, that was on 48 bits for routing prefix. So that one is constant. Now, how do you know? Now, usually, like you see here now, they usually start with 2 or 3. So IP address usually start with 2 or 3. So here we have 2. When you see 2, know the IP version 6. Let's see. Global addresses start with 2 or 3. So whenever you see this 2 or 3, it's telling you what that is IP version 6 address. Alright? So these are local addressing. So local address is usually other part of it. Right? Like you see here now. These are local addressing. Then we also have another portion called 16 bits. 16 bits are for the what? The network portion. They are for the network portion, like we explained earlier. So we have two parts of it now. This is 64 bits. 48 bits inside is for what? The global routing, right? 16 bits inside for the network portion. So but they all combine here to give you 64. Then the next 64 bits you see here is for host assignment of IP addresses. Right? Okay. So again, I'm going to talk more about IP version 6 address in networking essential class. Okay. So that brings us to the end of this session. So we're going to look at in our next video, in our next lesson, we're going to look at topic 5C and topic 5D. So stay tuned and follow our next video. We're going to show you, we're going to tell you about topic 5C, compare protocols and ports in the next video. So see you in the next video. Bye.